Hello guys, welcome on Tesla Adventures. In this video today, we are going to discuss the fluid dynamics, and the first topic which we are going to discuss in fluid dynamics is the types of fluid flows. So there are several type of fluid flows. You can see that there are steady and unsteady flow, one dimensional, two dimensional and three dimensional flow, laminar and turbulent flow, uniform and non-uniform flow, compressible and incompressible flow, and rotational and irrotational flow. But the main type of flows which are very useful in the preparation of the exams like JEE and NEET are laminar and turbulent only. So majorly we will be focusing on these type of flow in fluid dynamics. Okay. So first of all, let us discuss about the steady flow. So you can see that this is a real image of steady flow, and this is a streamline of water. So in this streamline, let us suppose that at this position the velocity of any molecule is v. So the velocity of every molecule at this position will be same v. So in steady state, the velocity, pressure, density of liquid is same, constant at any point of the streamline. It does not changes with time. है ना? And in the steady flow, the rate of volume flow of liquid through any cross section is constant, which means that the amount of liquid flowing through this cross section remains constant with time. It does not changes with time. And in steady flow, obviously all these conditions like pressure, density, velocity of liquid flow remains constant at any cross section of the liquid. But in unsteady flow, like the flow of water out of a plastic bottle, is a type of unsteady flow in which we cannot say that at any position the velocity of a molecule, if it is v, then the velocity of the other molecule will also be v at that position. So this is a unsteady flow. But you have done an experiment in which we put a straw inside this stream of water coming out of the bottle, then this flow becomes steady flow. Okay, so you can easily distinguish between steady and unsteady flow practically by using a plastic bottle. Now there is another type of flow which is called as uniform and non-uniform flow. In the uniform flow, the velocity of fluid which is flowing through the pipe remains constant throughout the pipe, which means that it does not changes with the space or distance, which means that there is a this is an example in which there is a pipe of constant cross section throughout, and the liquid is flowing through this pipe. So the velocity of liquid at all the points of the pipe will be same v. But if we use a pipe of variable cross section whose cross section is increasing, then the velocity of liquid flow through the pipe will change. And this is called as non-uniform flow. So in non-uniform flow, the velocity of liquid varies with the space or distance at any given instant of time. So we can say that now there is another type of flow which is called as rotational versus irrotational flow or non-rotational flow. See, when the liquid molecules are moving, translating on the streamline, as well as they are rotating on their axis like this. So this type of flow is called as rotational flow. And these are the liquid molecules, and when the liquid molecules are just translating along the streamline and they are not rotating about any axis, so this type of flow is called as irrotational flow. So this flow can be seen in near a big stone which is partially floating or which is partially immersed in a liquid which is having in a river which is having a very high velocity. So this type of flow is a rotational flow. Now let us talk about the laminar and turbulent flow. So first of all, let us discuss about the laminar flow. Now, as this name suggests, laminar flow means lamina. And let us see that in river which is having a broader cross section, you can see the river Ganga flowing in Rishikesh or Haridwar. So that river is having a broader or cross section, and hence the velocity of that river flow is not high, it is low. But that river flows into the layers, which means that the velocity of each layer of the liquid in that river is different, and the lowest velocity is of the layer which is in contact with the ground, and the highest velocity is of the layer which is the topmost layer. So velocity of different layers of that river increases as we are going away from the ground. Now this type of rivers should not be underestimated, because they apply a turning effect on the swimmer. Let me explain how. So let us suppose that this is a man who is underestimating this river and who is standing in the river. Now you can see the velocity here is very low and velocity here is very high. So this liquid layer is applying a greater force on the top part of the man as compared to a force which is applied on the bottom part of the man. So there is a torque which is turning this man like this. So this man will topple like this and will start to flow with the river, and his legs will be not in contact with the bottom. So these type of rivers should not be underestimated at any cost. Now this laminar flow is also seen inside a pipe. So let us imagine a pipe. In this pipe, the river, in fact the water is flowing in cylindrical layers. You can imagine that there is a cylindrical layer of liquid flowing through this pipe, and there is another layer of liquid which is flowing with some greater velocity through the pipe. So in this type of laminar flow, the sheets or the laminas are cylindrical in shape. So these are flowing through the pipe. Now in the turbulent flow, the liquid is having very high velocity, and some obstacles are also available in the liquid which are blocking the flow of liquid, and the liquid is flowing with very high velocity, so it becomes a turbulent flow. And turbulent flow is generally a random flow, and there is no analysis or there is no formula that is used to determine the turbulent flow. So now you can see that this is a simple type of flow, and there is a aerodynamic shaped obstacle which is kept inside this flow gently. So the molecules will change their streamline and will follow the curved streamline, but still they are following this streamline. But if an object of any arbitrary shape or sharp edges is kept inside this fast flowing river, then the molecules will be disturbed by the blockage of this obstacle, and there will be a turbulent zone in which molecules are absolutely not following any streamline. So this flow will be turbulent flow. And to determine the difference between the turbulent flow and the laminar flow, there is a number which is used, which is also called as Reynolds number. This is the Reynolds number. And the numerical value of Reynolds number is rho Vd upon eta, where rho is the density of the liquid, V is the velocity of flow, and D is the diameter of pipe, river or obstacle which is kept inside the water. and neta is the coefficient of viscosity. So if the value of Reynolds number is between 0 to 2000, then this type of flow is laminar flow. This is laminar or streamline flow. And if the Reynolds number is between 2000 to 3000, then this type of flow is getting transit from laminar to turbulent flow. Okay, this is in transit. And if the Reynolds number is greater than 3000, then this type of flow is turbulent flow. So guys, this was enough, and this was it in this video. And in this video we have already discussed the types of flow, but let me ensure you that the only flows which are very useful to us in JEE or NEET are laminar and streamline flows, and we'll be further discussing all the analysis of these type of flows in the next upcoming videos. Thank you.